often how things work in business in the real world. All right, so that's a spreadsheet. And those are my slides. Let's take that to slideshow. All right. So, thank you all for coming. This is, again, the basic title of Python and Spreadsheets. The title that I gave it on the official program is Growing Python with Spreadsheets. My name is Kojo Idrissa. I'm your presenter. So let's first talk about the title, Growing Python with Spreadsheets. My attempt to make a contribution to the Python community is through trying to find ways to help grow the Python community. I'm not the world's greatest programmer, and I may or may not ever be, but my thinking is that if I can help bring more people into the Python community, then they'll become better programmers than I will, and that's a good thing. I've also got a background in education and teaching adults and that sort of thing. So my general thesis is that if you are trying to grow the Python community, you are less likely to, well, the Python community won't grow by converting Perl and Java and C++ programmers into Python programmers. The Python community has a much better chance of growing by converting non-programmers into programmers. And so as opposed to trying to fight people and, it's a red ocean versus a blue ocean strategy. Instead of fighting where there's a lot of competition and trying to rip people away from their programming languages of choice, take people who aren't programming, and there are many more non-programmers than there are programmers, and introduce them to how Python can be useful to them in their day-to-day activities. So hence the title, Growing Python through Spreadsheets. So looking at spreadsheets in particular, if you're looking at people who are not programmers but may be close to being programmers or are closer than most people to being programmers, people who are heavy spreadsheet users tend to sort of fit that category because you're already accustomed to having to deal with different functions and trying to manipulate data and using it as an input to get some sort of an output. So that's one reason you look at those people. Another reason is because there's just a huge amount of data that exists in spreadsheets. They're not going away. And there are lots of people who are forced to deal with spreadsheets, whether they like to or not. They're forced to deal with spreadsheets. If you're getting the whole big data movement, you're getting data from the government and that sort of thing, it often comes in an Excel format or sometimes as a CSV, but there are a lot more people who know how to deal with spreadsheets and know how to deal with the CSV file or some other delimited file. And then there are also many business situations where you're just forced to use a spreadsheet. Someone gives you information in a spreadsheet and they're wanting you to process it and give them a spreadsheet in return. So there are a lot of situations where your input is a spreadsheet, just like with a Python function. Your input is a spreadsheet, your output needs to be a spreadsheet. But instead of fighting through an Excel or a LibreOffice or OpenOffice interface, there are a lot of things you can do with Python to get that data processing done. So now we're looking at combining those two, and hopefully it will help Python programmers be more productive when they're forced to deal with spreadsheets. And it will also help perhaps grow the Python community by taking people who are forced to deal with spreadsheets and introducing them to how Python can be beneficial to them. So that's the underlying premise here. The why, there's a lot of stuff that I've talked about already. Growing Python, there we go, growing Python. Also, there are lots of flaws in the way Excel is used for data analysis. So what you'll see, Excel, and I'm picking on Excel because it's been the dominant spreadsheet for the past 15 years. We all know that there are other spreadsheets. Actually, this presentation is being shown to you in LibreOffice, and when I show you a spreadsheet, it will be in LibreOffice because I don't have Office for Windows on my Mac. But when you are trying to do some sort of data analysis, when you're dealing with big data and data analysis, Excel and other spreadsheets have certain built-in flaws from the standpoint of they're partially automated and partially manual. So it's a visual tool. Most spreadsheets are visual tools, and so they often rely on the fact that, hey, someone's going to be looking at this data, and so the data doesn't need to be as clean or as structured when it's presented to you. You've got lots of different systems. A lot of my work background has been in accounting, so you've got accounting systems or ERPs, SAP or what have you, that will often spit out information in a spreadsheet format, Sometimes that data is clean and well structured, sometimes it is not. And one of the reasons it's often not as clean and well structured as a programmer would like it to be is because it's going into Excel and someone will be looking at it. And so if there are errors, if there are trailing spaces, if there are extra commas, if there are extra periods or whatever on the end or the beginning, someone's going to be looking at it, and so there's not a need to make the data as clean. But that creates problems, and a lot of those problems are problems that are more readily fixed or more efficiently fixed programmatically than by trying to sort of hammer on them individually with a visual tool like Excel. So, no, I'm not. There we go. But no. I'm going to talk briefly about the different spreadsheet formats. So you've got Excel, which is the dominant, but within Excel, you've got two different formats. If you're using Excel from before 2007, you have the .xls format, which we're probably all familiar with, Microsoft's binary format. If you're looking at Excel from 2007 or later, or Office 2007 or later, they've switched to an XML-based format, the XLSX format. And so if you're looking at dealing with spreadsheets programmatically, part of your decision is what are you going to work with. You've also got LibreOffice and OpenOffice that exist. Those will both read and write either format. So there are two libraries that I've come across and within Python. I think there are a few others, but these are the two that I've looked at the most. OpenPyXL, and the URL is there. And then the other library is really a combination of libraries. The XLRD, which was for reading Excel files, XLWRT for writing to Excel, and XLUtils is a set of utility functions that works with the other two. So the key differences here are that the OpenPyXL works with the newer XLS format, whereas the XLRD, XLWRT, and XLUtils work with the older XLS format. So the bottom set of libraries won't work with the newer formats, but they work very well with the older format. So when you're choosing something, you need to decide, okay, well, what do I need to work with? What do I need to actually interact with? I'm going to focus on OpenPyXL in this, partially because it didn't make sense to spend a whole lot of time focusing on an older format, and also I've just got a preference for the newer, more modern format. But there's also the advantage that the OpenPyXL also works well with the OpenOffice, LibreOffice, the other open source softwares, and so it made a little more sense to be presenting at PyCon about something that's going to work with something outside of just Excel. But if you've got a requirement that, depending on what systems you're working with, if you've got a requirement where those systems won't handle the newer Excel format, then you would need to look at the XLRD and its related libraries. So, what goes on here? And there are three basic steps. And let me point out here from the beginning that the Python here isn't terribly advanced. And so I think I sent out like a tweet last night just mentioning that this session should be fairly beginner friendly because there's not a huge amount of like super advanced new Python. It's all fairly basic stuff. So even if you just started learning Python, and then by show of hands, how many of you consider yourself new to Python? Okay. And so by new to Python, like how many of you had actually written Python code before you got here this weekend? Like, okay, so those of you who are new to Python, you had written some code before you got here this weekend. Okay. Is there anyone here who had not written any Python code until they got here this weekend? Okay, all right, and so when you ask people, are they new, that all sort of, it's this sort of variable range of like, by new, it means I can't build my own operating system on Python. Well, that's maybe not quite new, but, and I point that out because again, the focus here isn't on a whole lot of complicated Python. What should be new will be the things that are specific to this library, the new functions that this library adds to help you read and write from spreadsheets. But you've got your basic three steps, and if you've done any computing, you've seen those steps. It's the input, processing, output model. So, you've got a situation where you need to read data from your spreadsheet, and we can do that with Python. Processing the spreadsheet data with Python, and that's something probably, that code would probably look familiar to most of you. And then the writing the data to a spreadsheet with Python. So steps 1 and 3 are where you're going to see some things that may be a little bit new. But again, nothing terribly complicated. But this is also useful because being able to access spreadsheets directly also saves you from going through the intermediate step of, well, I can save it in a CSV file or what have you. And there are also a lot of other options. You could take the data, you could put it into a database and aggregate it and do all these different things, blah, blah, blah. I'm not really here to debate, or the purpose of the presentation isn't to discuss, are spreadsheets the appropriate technology for this task? This is dealing with the reality of, you know what, somebody gave you a spreadsheet, you need to give them back a spreadsheet. You've got to deal with a spreadsheet. What are you going to do? So, now if you've got other technologies available to you, that may be a better choice, but here we're focusing on the idea of if you're stuck with spreadsheets and you know some Python, what do you do? Or if you're stuck with spreadsheets and you don't know Python, what do you do? So here's where the excitement happens, the treacherous live demo. This is where I will actually switch to an editor and show you some actual Python code, which is full of all sorts of terrible comments. Well, no, actually, no, they're not terrible comments. Full of comments that were made as I was working this process out. It's fairly honest and straightforward. The Python isn't so great. I won't really cry. A little bit, maybe. The Python isn't so great, but it has advanced over time. So you'll see comments where I say, oh, I figured out a better way to do this. So I've commented out this old code, and now I've got new code that does better things. My next step that I'll get to later is that I need to get version control installed on my work laptop, actually. I need to get installed there to make that process of revising things a little easier. All right, so with that said, the treacherous lab demo. All right, so first, let's take a look at the data we're dealing with. So we have some anonymized company data here. Here what we're looking at is timesheet data. Speaking of timesheet, let me make sure that I'm good on time. So here what we're looking at here is timesheet information. And let me see. Well, let me see. Try to make that a little bit bigger. All right, Eloy, I'm going to count on you. Is that good, or should it be bigger? All right, gentleman in the red shirt, you're good, you're good, okay, all right. Audience participation. All right, and so, I need to turn off that data thing. All right, so, all right, there we go, so I need to turn that filtering off. It's blocking. All right, so what we've got here is essentially time data. If you've worked in different professional settings, I've worked in public accounting firms, I'm now working for an engineering firm. If you work in a place where you have to track your time and record your time separately based on different projects that you work on, that's what we've got here, a situation where you've got professionals who need to bill their time and code it to different projects that they're working on. So we've got an employee number, so each employee number is a unique employee. So you see here this first employee, they work for, this is not terribly important, this is the cost center that they belong to. This is, say, the company here represents, say, a subdivision within a larger organization. And there are only 3 of those, 1,000, 2,000, and 3,000. Those are the different main subdivisions. So this is a person, the specific cost center within their company that they were working in, who their manager is. This is the date they worked, and so you can see this is all data through the month of July. We've got 12,000 rows of data here. Some of these things aren't important. The employee name, important. Let's see. The contract that they worked on, this is important, this DOE versus project split. DOE being just direct overhead expense. And so it's a question here of, was this employee working on an actual project to which we can bill their time, or were they quote unquote unbillable? Were they just sort of overhead? And so this column had either project or DOE in it, and that determines what category that person is working on. And if they're working on a specific project, this contract number cell will give us what project or contract they were working on. And then here are the hours that they worked. And so this person, you've noticed the first two rows are the same person, but in the same cost center on different days, working on the same job number, but different hours. An hour here and then 3 hours there. So as you record your time, say through the day, this is what you get. And so we've got 12,000 rows of this, of different people reporting their time in different situations. What needs to happen is that all this information needs to be compiled into a report that shows what people worked in which of these cost centers and how many hours they worked in the month that were billed to that particular cost center, and of those hours, what was the split between project work and direct overhead expense work. So the way this had been handled before was a manual process. You think I just got this computer? The way this was handled before was a manual process where this raw data was put into a pivot table, and here you've got a summary. So you can see here, these numbers are badly formatted. Here you can see that for company 1000, there was 27,000 hours of DOE work that was done, 16,000 hours of project work, for a total of 44,835 hours of total work in that company, so on and so forth. And you can dig into the details of this to see different people and how much they worked in the different cost centers. So what would happen in the past was you'd have this pivot report. It would be filtered for one cost center. The summarized information would be copied from this pivot table, then pasted into another spreadsheet to just show the data for that cost center, and then wash, rinse, repeat, all done manually. It was a process that took 8 to 9 hours, all total. My point is, this gentleman here in the third row was like, what? And this is why I've written Python to deal with this, because it's sort of insane. However, that's not uncommon in the world of accounting. There are many reports that are created that way. You'll have a May report, and then you'll get June new information, and the way the June reports are created are by taking that June new information, copying it and pasting it into the May report, and then renaming that June. So this is how corporate America functions in many, many ways. Sad but true. So instead of the manual process, we've written Python code to make that work. So here I'm using, just as an aside, I'm using the Untitled Canopy Python distribution, partially because it has good support for NumPy and SciPy, which I'm honestly not really using here, but it's also a nice all-in-one integrated environment. I ended up putting this on a work laptop. It's a simple way to get a lot of the different Python stuff you need on a Windows machine, or just get it all set up in one place. If you don't want to spend a lot of time worrying about configuring, setting up your Python, one of these distributions will work well. So we go through two processes here. One process that gets done is that this gets summarized into one giant summary report that just shows all the different, that shows each individual person. Instead of 12,000 lines, you've got each individual person and their totals. But then, for these different cost centers that I mentioned here, you see 52 PO2, 57 100, there needs to be a separate report for each of those. And then each of those separate reports, each of these cost centers belong to some sort of functional group, say finance or engineering or welding or something else. And so those individual reports need to be grouped within their functional area. So this first bit of code we look at here, and let me, again, Eli? Right, let me know, is this when we get to big enough? Actually, this is good? All right, And I'm also going to get rid of this because you all don't really care about the files. I've got over here. File browser we don't need. So how's that? Viewable? All right. So first file we've got here, this head count Py file. This is going to take that raw data file and compile it down into, okay, instead of showing me each individual work segment for one person, I'm gonna pick on Eloy again. Let's say in the original data file, you see each time Eloy changed his time. So when he came in the morning, then he went to lunch, then he came back in the afternoon. So you've got all these multiple things for him. We want to just compress that all down, so I just want to see Eloy's totals for the month and for each other employee. So that's what we're going to do. Some basic timing stuff here. All right, so we start with actually loading in the workbook information from the spreadsheet. And so here, this load workbook function, this is something that comes from the OpenPyXL library. And so it's fairly self-explanatory. You're loading a workbook, you give it the file name. This file name is this headcountpyonon2, and that's the Excel file that I showed you earlier. And actually, let me make sure. One of the nice things about the Untitled distribution is it gives you a bit of a shell, and I need to switch directories to, let's see. Oh, wait. If only I knew how to use the shell, that would be helpful. There you go. All right, and so I just want to make sure I'm in the right directory. So, yeah, so in here, I can just switch the directories to the directory where I've actually got the file that I'm working on, and that makes it simpler. So here's the name of the file. Oh, I didn't change that. I need to change that. And so the source we're going to get here. The source, here's the workbook. I'm calling source, this is the actual tab within the workbook, the worksheet within the workbook. And it's, get sheet by name. You've got an option, you can grab workbooks, you can grab worksheets by indexing. You're just like the way you'd index like a list or anything else in Python. Or if you actually have the name of the worksheet, you can choose the name specifically. And I've renamed that sheet raw data. So the timer function, and this is just stuff I'm doing for timing. A print block I did for testing. So again, you'll see my weird comments in here that I've made as I've worked on this. I'm just starting a timer. So what I've done here, I'm just loading in the data from the workbook. And actually, I keep forgetting that this computer is slower than my old one. So I'm going to just run some of this code sequentially. Here you can see I'm importing from PyXL, I'm importing OpenPyXL, I'm importing workbook and then the load workbook functions, and I'm importing time from my timer functions. So I'm going to let these run for now. Let's see, what else do I need? Yeah, all right, so I'm going to let these run for now. Another nice thing that I like about the Untitled distribution is that it makes it easy to just run little chunks of code to see if something's working or not. This is my fairly basic development process of figuring out what's going on. All right, so while that's running, we'll take a look at what happens next. So as I've pulled in the workbook data, now I'm going to build a table that I'm calling table, and this is essentially, this table is a list of lists. It's just a set of nested lists where each internal list represents a row of data. Nothing terribly fancy. It could have been done as tuples. It might have been better to do it as tuples so they'd be immutable. But as I was trying to sort of work on this at work in the background, I'm an accountant, not a programmer, so at some point there's a question of, hey, why is that guy writing all that stuff with the funny colors on his screen instead of working in a spreadsheet? So trying to figure out how much code can I write before someone notices and says, hey, what's going on there? So I was trying to be expedient. So I worked with the things that were simpler that I knew best. All right, so we see here this is taking 56 seconds to load in this data. It's a lot slower, a lot faster on my work machine. So what I've done here, I've got this code, and you all can sort of read and understand this. But in the initial data, we've got 12,000 columns, 12,000 rows, 22 columns. The reality is we only need 7 of those columns. And so what I've done here, after I've read all the data in, and this is terrible practice, don't do this. I went through and looked and said, okay, well, which columns do I need? And I found those indexes, and I just made a list called ref, and those are the indexes that I need, and actually a tuple called ref, and for each column in ref, I pull out that data. And so now I'm just dealing with the 7 rows of data that I need instead of the 7 columns of data that I need instead of all 22. And this actually made it considerably faster. On my work machine, I've got these little comments here. It dropped it, but it made it like 50 times faster by just focusing on the 7 columns that I need. And we'll talk about some potential speed enhancements later, but we don't want to prematurely optimize our discussion about premature optimization. So get to that a little later. So let me run this little bit of code. And so that's going to construct this table, and this is going to be sort of the master data from which we work for the rest of our processing. And so you've got lots of stuff that here you're seeing sort of the remnants of things that I tried and either didn't work or they worked, but then I found a better way to do them, and so I've commented them out. But since I haven't installed version control, there's some things you don't want to lose, and you might want to go back later and look at, and so I've just got them all commented out because I'm a terrible programmer. Don't do this. Do as I say, not as I do. That's the important thing here. All right, so what happens next? I just want to make sure I'm not skipping over anything. So I'm constructing this table so that now I've got all my data in a Python data structure, and that's what's happening here. Basically, I'm constructing a Python data structure of the spreadsheet information so that I can start to process it in Python. So now I've taken the data from Excel and put it into Python so I can work with it as I would work with anything else in Python. So we've got a couple things here. I'm creating what I'm calling a list of keys. What happens is you want to make sure, if we look back at this original data, I'm creating a key based around my old slow computer. I'm creating a key that's going to use the employee number, the cost center, and the company number. So the rows A, B, and D here. There we go. So I want to make sure that I write a key that's here, here, and here, because I want to be able to match those up, because since I'm doing these total by cost center, and if we look at these first 2 people, what I want is a total for just that particular employee. So I'm creating this key that combines employee number, their cost center, the cost center that they're working at that point in time, and the individual company. So you could have a situation where one person may do work in more than one cost center within the same company, or in different cost centers within different companies. So trying to create a key to match stuff up so that I can then generate totals that way. And that's what this code is doing. So we're creating keys again. The keys, this would have been better implemented as, say, dictionaries, but I ran into trouble with that. So again, in trying to move forward quickly, I just went with lists again, with nested lists. And so here, I'm creating, with this range within the length of table, then this new key equals the first, a slice of the first 3 elements of each row within the table. And that's what gives us our key. And then this key list, I'm just appending it to this growing key list. And then here, and so the trick here is creating these keys, but then I'm going to need to use the keys to calculate the number of hours, because again, if we look back at the original data, for each person we've got a certain number of hours that they worked, and so I need to total these hours based on the keys, and the keys are essentially identifying each person and the area in which they worked. And so, let me start that code running. Let's It's a little more instructive if I make that a little smaller. So basically, I created a key list earlier. I'm going through the list of keys, and for each key in the key list, setting up these counters for counter variables for the DOE hours and the project hours, and then within that new row, I'm going through each row in my table construct. And if the key in my key list matches the first three elements of that row in the table, then I'm checking to see, okay, is the fifth element, is it DOE or does it say project? If it says DOE, increment the DOE variable, or add the values in the sixth element, which are the hours. If the fifth element is DOE, then add the value in the sixth element to the DOE variable. If it's project, then add that sixth value to the project variable. And this is what I'm using to count up the number of hours related to each key. So that's what this little bit of code is doing here. And then here, as the comment says, this next block of code is a hot mess. I was trying to sort of figure out ways to build this table of hours, and eventually I worked it out. As you can see, there are all of like 3 lines of useful code there. But eventually I got something working. After trying different options, but this is the nature of programming sometimes. You try different things and you see what happens. Uh-oh. Okay, I might need to. Oh, that's what happened. Oh, that's what I did. All right. Get the whole block. All right. And so this is how I'm creating my sort of list of hours. And now I'm creating what I'm calling final table. And this final table is what I'm going to use for my output, what I'm actually going to output, what I'm going to use for the output of the spreadsheet. And it's really just a matter of taking this information that I've processed before and matching it by keys, and then combining the raw information from the table construct, from the first 5 elements of the table construct, to the last 2 elements of the hour table, because the hour table is where I was accumulating those DOE hours and the project hours. And it's done this way because the output format of the reports that I'm generating is formatted that way. So you need to see certain things, but in the last 2 elements on the row are going to be the hours, the DOE hours and the project hours. And we'll see that in just a second. Run that. So there are a lot of things that are done here because I am trying to replicate this visual report that was already generated, and the people who are getting the reports are accustomed to seeing them in that fashion. So I'm trying to replicate some of that structure. But so here in this final table, I'm creating the structure, this set of nested lists that will eventually turn into the final spreadsheet. And so this is the Python data structure. Final table is that Python data structure that represents that. And then here, I'm actually writing a workbook, creating this workbook construct in memory. And so this here, target.createSheet, this is another just WS1, target.createSheet. This is something that comes from the OpenPyXL library. So this is when you need to create a new worksheet to store your calculations, this is how you do it. You target.createSheet, and then here I can give the sheet a title, so I'm calling it monthly headcount summary. So that's the little title that will appear on the worksheet tab. And let's see. And then I'm basically just taking that final table and processing through it to write those final table values into this spreadsheet construct. Did I create it? I probably left something out somewhere. Target not defined. There's probably a line here that I didn't highlight. All right, let's try this again. All right, what I might do is start that, and then just run all the code at once instead of trying to run it piecemeal and run the risk of overlooking stuff. What? Oh. When you restart your environment, you need to go back to where you were. Here we go. So where finding the file. All right, so I'll let that run. And again, it's embarrassing when you're the speaker and that happens. So I've stepped you through the basics of what happened here. I've created this worksheet construct. And here, so here, I've created the worksheets construct, and I'm writing the results for my final table into that worksheet construct. And so this is really the sort of the last bit of it. But the final step is you need to save that file. And so that's what we've got here. Earlier in the code, I came up with a destination file name. So here, just target.save. And then this is just my timing code to see what happens. And let's see. All right, and so here we see at the bottom, it took 57 seconds to process that. This is just stuff I was trying to do some basic profiling to see how long things were taking. Time to create this table construct that we see from this worksheet raw data for 12,355 rows. And it'll tell us how many columns in a second. So 2.9 seconds to create the table construct. Make that a little bit bigger. So you got my basic profiling information here. And some of this was for error checking to make sure that I hadn't left anything out. So I needed to make sure, okay, I know I've got 12,000 rows in the spreadsheet. I need this thing to have gone through 12,000 rows. So there's your basic profiling information. So what do you get as a result of this? What you end up with is, where's my, oh, did I close that already? Yes, I did. Oh, boy. That'll work. You go to this Word file. And we see that the newest file here, created just a few minutes ago, this headcount summary file. And so we go from 12,000 rows of data to, we go to about, we go to 7 columns of data and 490 rows. And so this tells you you've got these 490 employees. These are the amount of hours they worked in these 2 categories. So this is basic data, but this doesn't give us the final thing that we're looking for. What we want is to have that information broken out into functional areas, and unfortunately I've managed my time poorly, so I'm not going to be able to get into detail about this, but this code basically takes that summarized version that I just showed you, and I've got all these lists that name the different functional areas: engineering, project controls, project management, quality, accounting, and it takes those. Each list contains the cost centers that go into those different functional areas. And so what this code does is it will pull in that summarized data, sort it by cost center, and then create a separate tab that shows the summarized data for those groupings. And we will get another spreadsheet in probably another 30 or so seconds. So while that's running, and again, this is sort of an ongoing process where I'm sort of trying to refactor code. Here, the basic loading and getting the worksheets code that we saw before. I'm taking in the header rows here. I've got these lists that I defined with my different cost center groupings. And then I've got 2 functions here. Well, a full table function that creates a full table of all the information. So basically, it pulls all the information out of that summarized spreadsheet and puts it into a Python construct that I can work with. And that's what this full table function process does. And then I've got 2 different functions that create the summarized tables. One that I'm calling make sub C and one that's make not sub C. There's a particular cost center grouping where you have people who will work for different companies in the same group. And so for one of these, here for Make Subsea, I am, if you take a look at the information, we're excluding people from one of the companies, the company that's normally labeled as Company 2000. And so if you're not in Company 2000, this function says, if you're not in Company 2000, you won't be included here. This Make No Subsea table it's sort of its inverse. If you are in Company 2000, you will not be included here. And then again, just creating the workbook and writing information to that workbook. And then I've got sort of a main loop here at the bottom. Spacer stuff. I've got a main loop here at the bottom that creates these tables that I need to make my spreadsheets. So here I'm creating the basic tables I need to work with as Python constructs. And here I'm actually creating the tabs that I need. And this is still running. Let's see. Yeah, Python is still working hard. So I am working on trying to create a slightly more elegant solution instead of just having the same functions repeated over and over again with different inputs. I know there's a better way to do this. I just haven't had the time to work it out. This has been a proof of concept project, just sort of to see, okay, is it possible to actually get the output that people want and required programmatically? And here we go. And so despite my computer being sort of old and slow and running all this, so here it's finished this in 227 seconds. The end result is this head count function XLS. And what you have is a spreadsheet that should have 13 different tabs, which you can't see. So this is the overall summarizing tab, which is not terribly impressive. But if you notice, so here you've got the different groupings, quality, and there you've got the company, cost center, employer number, and then you've got these number of hours that they worked. And I convert these numbers to percentages. You can do formatting within this as well, with these libraries as well. That'll be just a low priority. So here you have a situation where you can see that these people have worked, they spent 14% of their time on DOE things, 86% of the time on projects, and so on and so forth. So that's my time. Thank you very much.